So what we have here are three-phase changeover contactors. The contactor on the left is the main contactor, the main incoming supply contactor. The contactor on the right is the contactor for the backup generator. So basically what happens is when there is a power cut, this contactor will pull out, but this contactor will pull in, and the backup generator will start, and electricity to the house will resume again. Now, as you might be able to hear, the contactor on the left hand side is making a buzzing noise, and that could be various things. One of the common things that I've been reading up on and why they buzz is that there could be a small amount of dirt in one of the contactors. So by simply taking them apart and blowing them out with compressed air, that might solve the problem. But I think what we probably will do, we'll do that, but we'll probably take both of them out and swap them round. And so this one is the backup, so the one on the left then becomes the backup one, as a temporary fix, just to get everything up and running, because even though it doesn't sound that loud, there's bedrooms directly above this room, and this buzzing is you can hear the buzzing quite well from there, so they want the buzzing to stop. So that's what we're going to have a look at and try to do today. Okay, so we have the two contactors that are now removed. Let's have a look at the top of the contactor. So we have the three phases on each contactor, and obviously the neutrals on the end. So these are 4-pole contactors, and then on the top we have terminals A1 and A2 on both. These are the coils, the coil connections, and in this case they are 240 volt coils. Let's have a look at the bottom, and again it's just the outgoing sides, it's just the outgoing parts of the contactors, obviously the 3 phases and the neutrals for both. Let's have a look on the back, and this is just how it connects onto the actual board. And so what we have to do is remove these screws, and then hopefully they'll just slide apart, and then this centre part in here, that's to prevent them, but that's an interlock. That's an interlock, and that's to prevent both contactors being pushed down together. Just by simply undoing the 2 screws that came apart, and then this piece of this equipment here, that is the mechanical interlock that goes between. So all we need to do is swap the contactors over and put the interlock back in, put the terminals back on, and then that should be okay. We have pushed the contactors in physically, and we've blown out all of the connections to make sure there's no loose dirt or anything loose in there. So hopefully this should be okay. And as you can see, the top of the contactors are all in good condition. There's no signs of anything burning out or anything, so it does look like they are in quite good condition. So we've swapped both of the contactors round. It was a little bit fiddly, but it's gone in okay.
Interlock works.
And let's just test to make sure that the interlock is working correctly.
Right.
So if we just push this one down, in fact, do you want to push that one down? If you push that one down, this contactor won't go in. If you push this one down,
that won't go in.
That contactor won't go in. So the interlock is working. Seems like it is working. So we've mounted the contactors back onto the DIN rail, which is this at the back. They've just clipped on to the back, and then there's a couple of self-tapping screws here that have just gone on just to keep it firmly on. So now the whole thing is nice and secure. Now all we need to do is connect the wires up. Started, and we've now connected the terminals to the 240 volt coil. That's all part of the control circuit. So there's the A1 terminals at the top, and there's the terminals at the bottom. They're connected. So they're two terminals. Just to quickly show you these two little coils.
No, not coils, they're
So
relays.
relays,
They're contactors. They're little contactors. Sorry, Matthew.
So these little contactors here, we didn't have to undo them. They just simply slot on here. There's a little spring here at the back, as you can see.
Little clip.
And that pushes in there. So it was easy, and it just slots in, and then it locks in, and they are both in place.
They operate when the contactors go down.
So we have installed the contactors, everything is connected up, and as you can see, there are lights and power is on. And so this contactor is pulled in, it's working. As you can see now, this contactor on the right is now pulled in, so that's the generator contactor. So what we've actually done is we're just testing the generator. And so what we've done, we've disconnected the main supply, and then after a 2 to 3 minutes delay, this contactor has pulled in.
After the generator started.
After just sort of a minute or so after the generator has started. We'll leave the generator to run for 5 or 10 minutes just to make sure that everything's okay and to allow it all to warm up, and then we'll turn it off. The reason why there is a delay of 2 to 3 minutes is simply because if there is just a power cut for 5 or 10 seconds, we don't really want the generator to start all the way up again, just for a power cut that's only a few seconds delay, just on for a few seconds. So, and also what you notice is that this is the contactor that was on this side, and it's not buzzing nowhere near like it was. So
We must have cleaned it up.
by cleaning it out like we did, which I don't think we showed on camera, but just we used a bit of compressed air and just shook it up and down, that might have done the job. But unfortunately we can't quite, we don't quite know, so only time will tell. So hopefully that should all be okay.